Today, we are embarking on a journey towards one of the most mysterious and energetic states of the universe. The Milky Way galaxy. Stars and natural events become even more striking and impressive thanks to this fourth state it contains. Plasma is a dazzling physical phenomenon that occurs when atoms and molecules ionize under temperature and density. The burning surface of the sun like a red fireball, the flash of lightning and colorful polar lights are examples of the impressive state of plasma. In this documentary, by delving into the depths of plasma, we will get to know this mysterious phenomenon more closely and discover how this energetic state of the universe sheds light on us. Plasma unlocks the mysteries behind today's technology and may have great potential in future energy sources, space travel and industrial applications. Plasma is a physical state known as the fourth state of matter. Unlike the other three states, it occurs as a result of the ionization of atoms or molecules. This happens when the gas is exposed to high temperature or density, which causes the atoms to lose electrons. Plasma is often observed in high-temperature astronomical objects such as stars, the sun, lightning, and natural phenomena such as the aurora borealis. This state of matter consists of positively charged ions and free electrons. These free electrons break the tight bonds between atoms found in conventional states of matter and demonstrate the electrically conductive properties of the material. It can emit light when interacting with electromagnetic fields and exhibit fluid-like behavior when interacting with magnetic fields. Plasma has a number of important differences compared to other states of matter. Electrical conductivity is lower in solid and liquid states of matter. Plasma, on the other hand, has the ability to conduct electrical current and generally exhibits a conductive behavior. Additionally, it has gas-like elasticity and can expand or compress depending on temperature and density. Unlike other states, when stimulated by electric current, it can emit light and appear colorful. For example, the colorful glows of stars and skylights are an example of this property of plasma. Plasma generally has low density and exists at high temperatures. This indicates that plasma is formed in environments requiring high energy and temperature. The Sun is a star composed largely of plasma. When we look at the internal structure of the Sun, we see that it consists of various layers and the core region is in plasma. The formation of plasma in the Sun is based on thermonuclear reactions that occur under intense heat and pressure. Hydrogen atoms are concentrated in the core region of the Sun. In this region, hydrogen atoms come together under high temperature and pressure and thermonuclear fusion reactions occur. In these reactions, hydrogen atoms combine to form helium atoms and a large amount of energy is released during this process. The high temperature and pressure that occur during these thermonuclear reactions ionizes the hydrogen atoms, meaning they lose their electrons. Thus, the core region of the Sun becomes plasma. This resulting plasma consists of free electrons and positively charged ions. The Sun shines with light and energy radiating from its core region, where the plasma is dense and at high temperature. This energy is transported towards other layers on the Sun's surface and causes various phenomena in the outer layers, for example, generating brightness in the photosphere and causing temperature fluctuations in the corona region. The properties of solar plasma help us understand the general behavior of stars and explore the energy cycle of the universe. At the same time, research on solar plasma contributes to increasing our knowledge on energy production and plasma-based technologies. Lightning is an electrical event that occurs as a result of a sudden discharge of electrical charge in the atmosphere between different regions. Lightning is often associated with the formation of a plasma characterized by high temperature and energy. Lightning occurs in high-energy areas in the atmosphere, usually during a thunderstorm. In these areas, electrical charge separation occurs between clouds or between clouds and the Earth. As a result of this separation, One region carries a negative charge while the other region carries a positive charge. Charge separation ionizes gases in the atmosphere, leading to the formation of plasma. Electrons are removed from the atoms and a plasma layer is formed between these free electrons and positive ions. The resulting plasma has high temperature and energy levels. The separation of electrical charges and the ionization process determine the path of lightning. A lightning channel is formed in the atmosphere and electrical discharge occurs along this channel. The movement of lightning along this channel depends on the dynamic behavior of the plasma layer in the atmosphere. The electric current that occurs during a lightning discharge releases a large amount of energy in the plasma. This energy produces electromagnetic radiation of various wavelengths, causing various phenomena such as visible light, sound waves and even radio waves. Therefore, the observed light shows and loud explosions of lightning occur due to the action of plasma. Lightning is an example of plasma formation caused by electrical charge differences in the atmosphere. These events indicate the ionization of gases in the atmosphere and the temporary existence of a plasma layer consisting of free electrons and positive ions. Thermonuclear reactions are processes of combining light nuclear particles under high temperature and pressure. These reactions generally occur in very hot environments such as stars and under thermal plasma conditions. Thermonuclear reactions require high temperature and pressure because they are processes of combining light nuclear particles. These conditions allow nuclear particles to overcome the Coulomb barrier and initiate nuclear reactions. These reactions usually occur in the plasma environment. Plasma is a state formed as a result of the ionization of gas under high temperature. High temperature ionizes atoms, creating free electrons and positively charged ions, creating plasma. The high temperature required for thermonuclear reactions ionizes gases. Ionized gases contain positively charged ions and free electrons because the atoms have lost their electrons. This facilitates the interaction between nuclear particles in thermonuclear reactions. One type of fusion reaction commonly seen in these reactions is the reaction in which hydrogen converts to helium. In this process, hydrogen atoms combine to turn into helium atoms, releasing a large amount of energy in the process. The release of energy that occurs during thermonuclear reactions contributes to maintaining high temperatures within the plasma. This energy keeps the atoms and particles in the plasma at a constantly high temperature. Galaxy formation refers to the formation of large-scale structures that emerged as a result of gravity and cosmic evolution processes in the early stages of the universe. In this formation process, plasma plays an important role in various components of galaxies. Galaxy formation begins when dense clouds of gas and matter in the youth of the universe come together under the influence of gravity. As clouds of gas and matter approach each other, the temperature and density inside them increase. This density and temperature cause the gases they contain to turn into plasma. Gases that condense and become hot become plasma as a result of ionization and electron detachment. The resulting plasma is usually arranged in a spiral structure or disk form. The movement of particles in the plasma tends to rotate under the influence of magnets, and this contributes to the formation of large disk structures within the galaxy. Gravitational interactions within the plasma can lead to local density increases and collapse of gas in these regions. As a result of the collapse of gas, new stars and star clusters are formed. These stars form the basic components of various structures within the galaxy. Stars may end in supernova explosions towards the end of their lives. These explosions enrich the plasma within the galaxy and trigger the formation of new generations of stars and planets. These supernovae continue the cycle of material within the galaxy. Various galaxies in the universe can merge to form larger galaxy structures. During these mergers, the plasma affects the characteristic properties of various galaxy types, and these mergers play an important role in galaxy evolution. Plasma radiation refers to the emission of electromagnetic radiation by ionized gases under high temperatures. This type of radiation can interact with plasma and other astronomical objects in space. Stars are composed of elements such as hydrogen and helium, usually in plasma form. Because of their high temperatures and pressures, stars produce plasma radiation. This radiation can be of various wavelengths, usually visible light, ultraviolet light, and X-rays. The Sun is constantly interacting with the release of charged particles into space, called the solar wind. This solar wind interacts with plasma environments found in space and can create magnetic fields. This interaction is an important factor affecting the distribution of magnetic fields and plasma in space. In the universe, intergalactic spaces and intergalactic environments often contain plasma. This cosmic plasma can produce long wavelengths of electromagnetic radiation, such as radio waves. Observed radio signals provide information about the existence and properties of this cosmic plasma. The plasma around black holes can be shaped by magnetic fields, which can turn the plasma into jets that spin at high speeds. These jets can be observed emitting electromagnetic radiation, and these events occur during the interactions of supermassive black holes at the center of the galaxy. Plasma radiation and interactions in space are an important area of research in astronomy, astrophysics, and space sciences. These interactions make significant contributions to the understanding of observed events and the analysis of the dynamics of the universe. The formation of the polar lights is an interesting and fascinating natural phenomenon. Northern lights are a natural sky phenomenon, also known as an aurora or magnetic aurora. In polar regions, they are called northern lights, especially near the North Pole, and southern lights near the South Pole. Some of these magnificent light events occur as a result of plasma interactions. Solar wind and charged particles from the Sun with the Earth's atmosphere plays a key role in the formation of aurora borealis. Charged particles in the solar wind are captured by the Earth's magnetic field and directed towards the polar regions. Energy is released when these particles hit the atmosphere. The collision of charged particles with the atmosphere ionizes gases in the atmosphere and turns them into plasma. Plasma is a mixture of free electrons and positive ions. The Earth's magnetic field interacts with the magnetic field of the solar wind in regions near the polar regions. This interaction creates a region called the magnetosphere. Magnetic field lines release energy by interacting with ionized gases in the atmosphere. The energy released produces the characteristic colors of various gases in the atmosphere. For example, the interaction of oxygen can produce green and red colors, and the interaction of nitrogen can produce purple and pink colors. Auroras can often be round or ring-shaped and dance in specific patterns. These patterns result from the interaction of magnetic field lines with the plasma in the atmosphere. Polar lights present a visual and colorful feast that occurs as a result of plasma interactions. These atmospheric phenomena light up the skies in the polar regions, creating a unique and impressive natural phenomenon. Researchers try to learn more about the interactions of the atmosphere and magnetosphere by studying aurora events. Plasma power plants are energy production facilities where plasma technology is used. Such power plants are interesting in terms of low-carbon energy production and waste management. Plasma power plants use waste materials to convert them into plasma. In this system, called plasma furnace, which operates at high temperatures, organic and inorganic substances in the waste turn into plasma. Plasma power plants thermally break down solid waste and convert waste into energy. The high temperature and energy in the plasma breaks down the molecular structure of the waste and energy is released. It also produces electricity using the hot gases produced by the plasma. This electricity can be connected to the grid and become a source of energy for users. Advantages of these power plants include low carbon emissions, waste reduction, energy production and the ability to process various types of waste. Additionally, plasma energy plants allow for the safe disposal of hazardous waste. Plasma physics laboratories are centers where the plasma state of matter is examined. These laboratories conduct studies to understand the properties, behavior and interactions of plasma using various plasma generation methods and recognition tools. These methods include technologies such as tokamaks, which form the basis of fusion reactors, laser plasma generation, and radio frequency ionization. Plasma laboratories obtain scientific data by examining plasma behavior through magnetohydrodynamic analysis, spectroscopy, radiation analysis and various plasma recognition methods. These data provide the basis for theoretical studies as well as applied research in the field of plasma physics. The fact that plasma contains energy production potential, especially for fusion reactors, increases the importance of research conducted in laboratories. Plasma-focused scientific projects are projects that focus on plasma physics and applied plasma research. Such projects aim to understand and control the properties of plasma and use it in various industrial or energy applications. Fusion is a type of nuclear reaction that produces helium and energy by combining hydrogen isotopes. These projects include topics such as developing fusion reactors and controlling plasma temperature and density. Large-scale projects such as the International Thermonuclear Experimental Reactor explore practical applications of fusion energy. Plasma can be used for the modification and production of materials by providing high energy and temperature. These projects focus on achieving new material properties by improving plasma-based material processing methods. Plasma-ion engines for spacecraft propulsion systems use the principle of propulsion by high-speed ions. These projects aim to develop plasma-ion engines for more efficient and long-lasting spacecraft. Rocket exhaust and ion thrust rockets have different technologies used for spacecraft propulsion systems. Among these technologies, plasma plays an important role in providing thrust, especially in ion thrust rockets. Rockets base their thrust principle on Newton's third law of motion. Every action creates an opposite reaction. Rockets generally implement this principle by using flammable fuels and oxidants. The gases formed during the combustion of the fuel are pushed towards the back of the rocket, and this gas flow moves the rocket. Ion thrust rockets have a different operating principle than conventional rockets and use plasma technology. In these rockets, a gas, usually xenon, is brought to an ionized state. This ionized gas is accelerated using electromagnetic fields and pushed towards the back of the rocket. Plasma is a state in which this ionized gas is created. Electrons and ions move freely in a high-energy environment, forming plasma. In ion thrust rockets, this plasma is accelerated to provide thrust and propel the rocket. The exhaust of conventional rockets generally consists of high-temperature and fast-moving gases. These gases usually include water vapor, carbon dioxide and nitrogen. Rocket exhausts generally provide thrust at very high speeds, but have higher fuel consumption and a shorter lifespan. Ion thrust rockets can reach higher speeds thanks to the use of plasma technology. Although plasma thrusters provide low thrust, this thrust is continuous and long-lasting. This feature is preferred in spacecraft that require long-term and precise maneuvers. Plasma televisions, on the other hand, use a display technology that produces light by converting gases, usually neon and xenon, into plasma. Plasma displays contain a glass panel with a microscopic cell behind each pixel. These cells are filled with gases, and when an electric current is applied, the gases turn into plasma. Plasma produces UV light, which creates an image by affecting the phosphor-coated cells on the front surface of the screen. Plasma televisions can offer a wide range of colors compared to some other display technologies. Each pixel's unique ability to produce light provides rich colors and high contrast ratios. Over the last 10 years, the production of plasma televisions has largely stopped and has been replaced by LED technology and OLED technologies, which are more energy efficient and thinner. Don't forget to subscribe for brand new documentaries and more scientific content.